Error. So in this lecture we're looking at the hydroboration oxidation of alkenes. This follows the Anti-Markovnikov rule. So let's take this alkane, for example, and our reagents here, pH3 and THF is our solvent, and for our second reagent, the hydration, we have hydrogen peroxide and sodium hydroxide, and our product will be giving us this primary alcohol here. Note this is obviously Anti-Markovnikov's rule, so we wouldn't get our alcohol coming off here. It would be off the least branched carbon. Okay, what's really important here is more so the mechanism, the reaction itself, so let's look at that. Okay, let me just draw it lengthways here, and essentially what's going to happen here is double bond from this carbon is going to attack this hydrogen here, and this boron is going to bond to this carbon here, and how to represent that is just this white curly arrow that I've shown here. And the boron attacks and bonds to the least hindered carbon. Okay, so we now have our BH2 and our hydrogen coming off here. So it's also good to note down as you're going through the reaction mechanism what's sort of happening. So boron bonds to least hindered carbon, which is obviously going to be the carbon here because it's not attached to any other. It's only attached to one other carbon. Right, so this reaction continues. So we have more reactants added, and the reaction keeps repeating until we have nothing left bonded to this boron atom. So I'm just going to add another pointer here that reaction repeats. And we now use our reagents, our second set of reagents of hydrogen peroxide and sodium hydroxide. And in combination, these both form this ion here. This ion here sorry, pardon me. Just really quickly, this boron should be attached to all the hydrogens have been substituted for more of that alkene. Okay, now we use our reagents, so our NaOH, so our sodium hydroxide and our hydrogen peroxide, to give this ion, and what this forms is a our beryllium ion. So, like so. Okay, now that we have this, a few things are going to happen here. So this OH becomes a reasonable leaving group, and one of our methyl cyclohexane are going to move and replace the OH. So what happens essentially is we have an arrow coming around like this and like this, and we form this molecule in right here. Sorry, we're going to be forming our borate esters. Borate ester right here. Like so. Okay. And we'll just give a little simplified version down here before the hydrolysis, where we have just a simplified version of our borate ester here. We'll name this our borate ester. Then we're using basic ester hydrolysis with our OH ion, our hydroxide, from the sodium hydroxide to form our primary alcohol, like so. So a reasonably long mechanism here. This is a pretty simple version of it. And so there's even an example here with the straight chain alkene 1-butene, where we form OH. Something I'll look at in the next video will be acetoxymercuration, where we'll look at where Markovnikov's rule is in place for oxidation of alkenes. Thank you.